This is a video on regular expressions. Regular expressions are a part of Python, but they're actually a language of their own, and they're not limited to Python. Regular expressions are implemented in a number of other languages, including the ones you know, JavaScript, Java, shell scripting. Many other languages incorporate regular expressions into their distribution. And a really good question would be why? Well, earlier in this course, we spent time figuring out how to get pieces of text out of a larger text, right? When you see a line like this, and I ask you, let's say, to get the year, 1934, out of this date, you know how to do it. You're going to do it by position. But if I ask you, let's say, to get the 8-digit date out of this string, this comma-separated string, you would think about using split most likely. In other words, you would consider the text either positionally or by a pattern that's in the text. And of course, the pattern of a CSV line is the comma separators. And regular expressions kind of make use of that idea of detecting patterns in a text. If you consider another example, for example, what you're looking at here is the beginning of a web server log line. If I asked you to identify, let's say, the IP address or the 4-digit year or the month, you could do that relatively easily. Web server log lines are pretty easy to read. If you know what an IP address looks like, it looks like this. And if I was to ask you to describe the pattern of an IP address, not the specific characters involved, but just the pattern, you'd say, oh, it's like between 1 and 3 numbers, I think, and then a dot, and then between 1 and 3 numbers, and then a dot. I mean, if you knew something about IP addresses, you'd say that. And this is the pattern of an IP address. It's 4 different 2 to 3 or 1 to 3 digit numbers separated by periods, similar to a CSV line in a way. And if I was to talk about the date on this line, and we would look at log lines, we'll look at a bunch of log lines from a web server log, you can see that the date is formatted according to a specific pattern as well. Well, identifying this pattern, that is identifying the expected succession or sequence of characters, not in terms of specific characters, but in terms of a pattern, like a date pattern, an IP address pattern, an email address pattern, a telephone number pattern. That's what regular expressions are about. If we wanted to extract the IP address and the date from this string, we could probably figure out a way to do it using split. But you can almost think of regular expressions as a far more sophisticated split. Split just says, okay, look for this character or characters and divide this string on that. But regular expressions say, I'm looking for a pattern. I'm looking for 1 to 3 digits followed by a dot, followed by 1 to 3 digits, followed by a dot, etc. Or I'm looking for 2 digits followed by a slash, followed by 3 letter characters, followed by a slash, followed by 4 digits. That's what regular expressions does. It produces a pattern that indicates what we're looking for. And we'll be using this pattern to either match on text and say that the text passes the pattern or matches the pattern, and also to extract. Now, what you're looking at here in this regex is the beginning of a regular expression, or regex, that describes the pattern that I just mentioned. I think I said 1 to 3 characters, digit characters, it doesn't matter. But let's read this regular expression just as a preview to show you how this little mini language works. What this pattern is saying is, I'm looking for 2 to 3 digits, followed by a period, followed by 2 to 3 digits. Now, when you look at something like this, if I tell you that that's 2 to 3 digits, I think you can see, what's what. \D represents a digit. 2, 3 says 2 or 3 of these. And what we're looking at here are two specific features of regular expressions. That is a character class, which will match on any class of characters, in this case a digit. It'll just match on any digit from 0 to 9, it'll match. And then this quantifier says how many of those we're looking for. And this is the beginning of our understanding of regular expressions, that we can say, it's one of these kind of characters, that is, let's say 0 to 9, and we can say how many there are as well. And then you see parentheses around these. Parentheses allow us to group and, if we like, extract text that's matching. So you see my log line here. It's got this IP, and you can see this regular expression which seeks to match on that IP. And the parentheses around it allow us to extract the text that was matched. You can see that when I say reg.group1, I'm getting the IP. Now, of course, this is a preview, so you're not expected to remember everything. We're going to go over this in detail. But this is what we're doing here. We are matching on a pattern of text. We are matching on text that we know may follow a particular pattern. And so, again, the regular expression language is designed to allow you to identify a pattern that you're looking for. And think about other patterns in text that we might want to look for. For example, we might look for an HTML tag if we really wanted to. We don't need to use Beautiful Soup to match on an HTML tag, because an HTML tag has a specific pattern, doesn't it? It varies between tags, but all tags follow the same pattern. Or an email address, telephone number. We mentioned these earlier. So let's begin the process of matching. Now I'm going to move really quickly. You can, of course, pause wherever you like. I'm going to try to make this video short and cover everything that we need here. This will just be a very basic introduction. But this is our first regular expression, and what I'm doing here is I'm looping through each line, and I'm kind of simulating some sort of search that we might do. But the operative line that we want to focus on is this one, in which we're taking any given line in the list, right? This is like a list of the lines in the file, and we are applying a match. To do this, and I've left it out here, we're going to import RE, and I see I did not import RE, but that's what you would see first. You'd see an import RE. Yeah, I have that here. That's what should be there, an import RE. I think in a number of these examples I don't use it, but you should imagine that it's there. We're going to import RE because the regular expression engine is part of a module called RE. And we're going to say RE search. And search takes two arguments. The first is a string that represents the pattern, and the second is a string that represents the string that we're trying to match on. Now you can see that the pattern is ~JJK265, and there's actually no regular expression entities involved in this. This is the simplest kind of pattern that we might look for. It's one in which we're actually looking for specific characters. I'm specifically looking for the tilde character, that's the wavy curvy thing there, the tilde character followed by JJK265. And you can see that in my source data of 3 lines, there are 2 lines here that match that pattern. So focusing on the RE search, we see it in a Boolean expression, and search will return an object that may be seen as true or false. If the pattern ~JJK265 matches any given line, then that statement will be true. This is the beginning of our use of RE search. We'll go further than that a little later. But RE search is about matching or not matching. And that's what this is doing here. It's matching this pattern. Now, when we move on and do something more sophisticated, of course, we can also put a not in front of it. So this is going to match on any lines that don't have this pattern. And also, sorry, just to describe what this R was, you may have noticed in the earlier examples, my first string has an R in front of it. You remember that there are certain kind of qualified strings like the F string. This is the R string, and an R string stands for raw string. we need to use it when we're using regular expressions. And that's because regular expressions make use of backslashes, as you saw in our initial example. So the only thing you need to remember about raw strings and regular expressions is that anytime you do any kind of matching, the pattern should be in a raw string. It doesn't really matter if it has objectionable characters or not. We're going to use the raw string. Now, I'm not going to say a lot about it except to say that in most strings, when you use a backslash, we call that an escape sequence. Backslash n is a specific sequence of characters that actually represents one character. Of course, we know what that character is. It's the new line. So backslash n, which in our code is 2 characters, resolves to a single character called the new line character, and we notate it using this escape sequence. Backslash n is an escape sequence. So if we say var equals backslash n, and I don't really need quotes here, I'm not sure why I have them here. If we say var equals backslash n, that actually is a length of 1, believe it or not. A length of 1, which means 1 character. But if we look at the length of the raw string backslash n, we're going to see that that backslash is no longer part of an escape sequence, not in this string. Because Python by default will look at backslash and say, oh, backslash, okay, that's a escape sequence. And so I'm going to take the next character as part of that escape sequence. But what raw says is, no, I don't engage in escape sequences. So this is 2 characters. It's the actual backslash character followed by an actual n. And that's what raw string is about. You're going to see that in all of the examples we use, I put an r in front of the string, whether it's really needed or not. That's what we do with our regular expression patterns. Now, before we go further, I'd like to just introduce you to this slide that indicates the entities that we're going to look at. You may remember in our earlier example, we had a backslash d, and then we had a curly brace 2, 3. These are special entities that make up the regular expression language. Regular expressions is not a complex language. It's not a super extensive language. It's something that they call a declarative language, meaning it's not a language that engages in things like logic, maybe not very, very extensive logic. It's not a programming language like Python or Ruby or Java. It's a declarative language, similar to SQL in the sense that it says, okay, this, right? SQL says, okay, this, like this query, I want this thing. It's very specific, and we call it declarative rather than, let's say, a procedural language like Python that proceeds from statement to statement. This declarative language consists, in our analysis, it goes a little further than what we're going to look at today, but this actually is a pretty complete rundown of all the most important and useful features, specific entities or language elements of the regular expression language. And you can read these. I would suggest you pause and read through these. We're going to go over this, but I want to begin with a bit of an overview so you can see where this is all going. We basically just have, besides the anchor and boundary, we have character classes and quantifiers, and also groupings. Character classes, which really make up these 3. Quantifiers, which make up these 2. And groupings, which we're going to look at last, and represents this 1. So what the character classes say is which characters will it match, like let's say the digit 1 we talked about. The quantifiers say how many, and we use them together, right? How many digits? We saw that before. Let's go over this step by step. I'll say briefly before we look at the entities that there are a couple of rules to keep in mind when you're looking at regular expressions. The first is the idea that matches will only happen on consecutive characters. Keep this in mind. If my pattern is HELLO, will it match here? Yeah, absolutely. Will it match here? Certainly, same idea. Will it match this? No, will not match. Why? It does have HEL and LO, and they're in the same sequence as the characters we're looking for. But the first rule to remember is that any match is going to happen on consecutive characters. And so this would match HEL space LO, but not HEL LO. And a space, of course, is a character just like any other. You shouldn't think of it as an absence of a character. It is a character. It's kind of invisible, but you can see it, right? You can see the space between its left and right neighbors. So it's there. It's a space. The other thing I wanted to mention was that a match can happen anywhere. So when you look at a match like this, a lot of times early on, you might expect this pattern to only match on a string, a 5-character string that's HELLO. But you can see that not only will it match at the beginning of the string, it'll match in the middle. Got to keep that in mind as well, because some folks kind of forget that a pattern can match anywhere in a string. It doesn't matter where it is. If Python can find consecutive characters that match this pattern, it's going to approve the match and say that that matched. So let's begin our tour of the bestiary. And again, you may want to keep that page open if you have an extra screen or extra space on your screen. Maybe keep the page open that shows the entire bestiary, we sometimes call it, and show how what we're looking at corresponds to what we're seeing here. It's a pretty small group. The real challenge with regular expressions is going to be in understanding the combinations that we can create to do sophisticated matching. Let's begin with the boundary. Remember in the beginning, in our last comment, we said that patterns can match anywhere. But there are some cases where we might want to match only in one specific place, like let's say the end of the string. For example, if you're looking at a file name and the file name ends with .txt, well, you can match and specify .txt match with an anchor. This is our first entity, the $, which represents the end of the string. We're saying that if the file name we're looking at, which here you can see we're listing out the files in this directory, and if this file name is, let's say, hello.txt, it should match here. But if it's .txt hello, it would not. That's because an anchor says, I match only at the end of the string. Similarly, here we're matching on what? This caret means match at the beginning of the string. That's what this special character means, the caret. It's saying that I'll match on any line that has a hash mark, but the hash mark needs to be right at the start of the string. That's what I'm looking for there. So these are our first two special entities, the $, which means anchored to the end, and the caret, which means anchored to the beginning. And as much as it may be possible, you should start to memorize, or at least keep that key, that we showed in the earlier slide. Keep that available to yourself so you can always look these things up. Because these are, like I said, there aren't that many to learn, and so we can learn them pretty quickly. The big challenge will be in reading your regex and constructing your regex based on a complex pattern, as I just said. Okay, so anchors, beginning and ending. Now, you may have noticed that we're using a backslash in the string. Now, some characters are special on their own, like the dot. A dot is actually special, and we're going to talk about what that dot means. So if we actually want to match on a period, that is a period character, we're going to need to backslash it to mean that. Because backslash dot means I'll match on an actual text dot. But an unbackslashed dot actually matches on just about anything, and we'll see that in a second. So first bestiary characters, the $, and the caret. Now if you see a $, employed as an anchor, it's certainly going to appear at the end of the pattern, and same thing with the caret, right? Because they're specifying end of the string or beginning of the string. So that's why they'll appear in those places. Our next major entity and our next major category of entities is called the character class. Now, as I showed you before, and if you think about how relevant this is, if I'm trying to match on a telephone number, what am I matching on? I'm matching on a 3-digit area code, followed by a dash, followed by a 3-digit exchange, they used to call it, followed by a dash, followed by a 4-digit number. These are digits, and you know that a telephone number can be any of the digits. It could be 212, or it could be 312, it could be 909, it could be any kind of area code, and the numbers can also be any numbers for the most part, or we can just assume that. So to be able to match on any digit, we need a special entity, or we can use a special entity, \d. \d means digits. I'll match on a digit. I'm not going to match on all of the digits. I'm going to match on any one digit. The word character class is a little different. \w suggests a character class that covers all of these characters. It's a little bit of a misnomer, but it comes out of Unix culture. Word means letter, number, or underscore. And that's what a word character is. So just like a \d would match on a 6 or a 3 or a 9 or a 0, \w will match on an uppercase D, a lowercase f, a 4, an underscore. This character class matches this list of characters shown here. And then the space character class represents any one of these three. Now we're using \, as an escape. The \n means a new line. The \t means a tab. Well, I'm just showing you which characters will match the \s. The space character class, or white space they call it. It'll match on any three of these characters. Now, we've got some examples here, which I'm going to go through pretty quickly, not spending a lot of time. You can slow them down or even in some cases try them out. And I'll try to produce a list of examples for you to work with alongside of this video if you wish. Here we see that we have a pattern here, which is a 4-digit year followed by a 2-digit month and 2-digit day and then .txt. And look, we're using all the entities that we've learned so far, at least a character class and the digit class. But can you see how this matches? It's saying from beginning to end, I'm looking for digit, 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 dash, digit, digit, dash, digit, digit, dot, txt, and it must end there too. You can see that we're able to use this to identify certain files that might be in our file listing and to separate out those files from the ones that don't match, because maybe there's some extra files or maybe other entities like these two built-in directories that you see in file listing. We can ignore those and also ignore any non-matching files by simply using this pattern. Same thing would be true if you were looking for a 4-digit year. You could just ask for it in one shot. You may remember in our earlier endeavors, especially if you took the intro class, we might have validated a 4-digit year by checking its length and also checking to see that it is digit, right? The Python string is digit method. But here we can do it more elegantly by asking, is it 4 digits? Is it consist of 4-digit characters? Word characters are very similar. I'm looking for any letter. And if you're, let's say you wanted to create a username validator where someone's going to create a username for your system and you want to validate it so that it only matches on letters, numbers, or the underscore, you could use this word character character class. Same thing with spaces. Maybe you want to detect a space somewhere in someone's input, make sure it doesn't have any spaces. Let me give you a little quiz now. This is, okay, but first let me just say, this is looking for a space character anywhere in here. You see, we're using it for validation here. We're not looking for a specific type of string or a specific pattern. We're really just looking to see that there are no spaces in there. And that would include new lines and tabs. So that's what this test is saying. If it has a space character anywhere in it, then print this error message. Now we also have the inverse of what we were talking about, the non-digit character class that says, I represent a non-digit. So let me ask you, which characters would be included in a character class that says non-digit? Well, the answer is there's quite a few, because if you think of what characters are not digit characters, that would include all the letters, all the punctuation, spaces, and probably some other characters that you've never seen before. They would all match on a non-digit. Here we're using it for validation. If the person's account number is a non-digit, then we give them an error message. Here's the non-word. Again, looking for, maybe you wanted your account number to be all word characters. You could validate that the way we did earlier, which was this is asking for 5 word characters. If it's 5 word characters from beginning to end, then it's good. Or if it's not that, then it's bad. This is saying the same thing, more or less. It's not specifying 5. It's saying if I find a non-word character in this account number, then obviously there's a problem. What's a non-word character? Well, what's in the word character class? The digit character class is easy. There's 10 of those characters. How many characters would be in the word character class? Well, the answer is 37. 63. It's 26 lowercase letters, 26 uppercase letters, 10 digit characters, and the underscore. That's what's in the word character class. But look, I'm going to show you the inverse of word, a non-word character. So what is included there? Well, punctuation, spaces, and probably other characters. But punctuation and spaces would be non-word characters. Same thing with not a space. Not a space matches on everything but the space. Everything but a space, new line, or tab. So you could say, type me a sentence, but make sure there are no spaces in the beginning. And unless you find a non-space at the beginning, that's what this is saying, then maybe you could give an error message, or you could strip the string or something like that. This is saying I'm looking for a non-space at the beginning of this string. Now the custom character classes take it just a little further, because the built-in character classes will match on any one of a certain set of characters, but the custom character classes will match on anything within a list. Now look closely at the lists of characters that I'm showing you here. 0 through 9, right? All the uppercase, lowercase, and underscore, right? And numbers, and the space character class. Well, a custom character class is notated in this way. If you wanted to create a custom character class that only matches on digits, it would look like this. Which means that if you wanted to specify that it must match only on the first 5 digits, or any digit greater than 5, or whatever you'd like, you can specify that in the custom character class. For example, what's weird about the word character class for me is that it includes numbers. And I didn't really understand that, because you would think that a word character class would just be letters, because we're talking about English words. Well, it turns out that Unix word is a little different, and that's maybe why they call it a word character class. But you know that we may want to look for a pattern that says, I begin with a letter. Do you see that this pattern says that? It says, I'm looking for something that begins with a letter. I'm looking for a letter here at the beginning of the string. So that's what that's saying. Our custom character class can specify lowercase or uppercase letters. And you can put whatever you want in there. And they don't need to be ranges either. Let's look at this. This one is a little bit difficult to parse out. You might want to pause and see if you can understand it. But basically, it's breaking up this string into words and then removing any punctuation that it finds. The custom character class says, I represent any of these characters. So if at the end of the string you find a period or a question mark, let's get rid of it. That's what this is doing. Don't worry about the while and everything else. It's basically just saying, if I see at the end of a string, and we're looking at each individual word like this, and this, and this, and this, that if I find at the end of a string any of these characters, and then of course the $ means at the end, then I'm going to remove it. It's basically just taking it right off the string. That's what that's doing. We also have the capacity to specify the inverse of a character class. That is, any character that is not a member of this class. So similar to the inverse character classes \D, \S, \W, inverse, right? The inverse of those. This is doing the same thing. Now this is a little bit confusing because you may remember that we used the caret earlier. How did we use the caret initially? What did we mention that the caret was for? Caret means at the beginning of a string, doesn't it? We can see this a little earlier when we first looked at anchors. This is saying I'm looking for a hash mark at the beginning. You can see that the caret is there on the left. You can see that it represents the beginning, or that is followed by a hash mark. And because we put it at the beginning of this pattern, it's saying from the beginning of the string, I want to see a hash mark. I'll match on that. So when you look at our inverse character class, when we look at the custom character class, if you're interested in seeing an inverse of that, there it is. And you want to say, I'm going to look for a non-letter at the beginning, or I'm sorry, non-letter at the end. A non-letter at the end. Yeah, we did that before with punctuation. But this is saying, I'm looking for a non-letter at the end. Now, non is controlled by this caret. And you'll notice that this caret is not at the beginning of the pattern. It is inside the open bracket. That's what makes it an inverse character class. This has nothing to do with an anchor. This character has nothing to do with matching at the beginning. This is simply saying, I'm looking for a non-letter at the end of this string. Okay, I may have said begin earlier. I'm looking for a non-letter, because if there's a non-letter at the end of the string, then I want it taken off. And that's what that's doing. Our final character class is called the wildcard, and it's represented by a dot. You remember earlier I mentioned the dot. The dot is actually a special entity, and the reason I had to backslash it earlier is that it is this special entity. This dot matches on anything except for a new line. Does not match at a new line. What this is saying is if the user gave you, let's say, a 5-digit username, and they could use whatever characters they want, I guess including spaces. So this isn't a terrific example. You can use the wildcard to say, I'll match on anything. I'll match on any character except for the new line. And so this is basically saying, I'm looking for 5 characters in a row from beginning to end within the string. Okay, I'm going to pause for a moment. We'll resume with the second video when we start talking about quantifiers.